Hi everyone. So today we are going to be learning how to graph square root functions. So for example, f of x equals the square root of x, which is the parent function, which you should have seen and explored in your Desmos activity yesterday. So today we are going to continue talking about that, continue to talk about graphing these functions. Now, there are some similarities with graphing quadratics because they follow the same rules as far as transformations. But you have to think about what the square root means and what it represents and how we use it, because that's going to be important when we start making, for example, our table of values, and it's going to affect what numbers we can plug in for x. Because like I told you in class, in this unit, we're not using imaginary numbers. So we can't take the square root of negative numbers. So I want you to keep that in the back of your mind as I start going through the notes and kind of explaining everything. So let's do that now. Okay, I forgot to mention, since this is a video, please feel free to pause, rewind. Anytime you need to kind of gather your thoughts or go back and review something that I mentioned. So let's get learning. Okay, so these are the notes I put up on Google Classroom. So we are just going to go through these and I'm going to just explain as the best I can. Please comment on this and let me know if you have any questions or concerns or any constructive criticism as to how I can do better in the future. Okay, so let's get started. So on the left side here, we have a page that is going to explain the parent function of the square root functions. You guys have pages like this in your notebook on page, I believe it's 16 or 15, where we went through the different other parent functions. So for example, the linear function, quadratic function. So this was supposed to go in your notebook, but you know, we'll wait on that. Okay, so the parent function for square roots, as you saw yesterday in your Desmos activity, is represented by f of x equals the square root of x. Because remember, parent functions are the most basic form of the function with no transformations or anything. And so then we want to graph this function. So we are going to need to make a little table of values. Now I'm actually going to do that at the bottom since that's where I have more space. So our table of values, so as you know, I like to make 3 columns with our inputs, our outputs, and then just a middle section for us to show our work. So now this is kind of going back to what I was talking about before. You have to remember what the square root of x represents. And how do we take square roots? So usually when we're taking square roots, we're looking for perfect squares because we don't really want to have to deal with decimals or anything. So when you're plugging in your x values, you have to think about, okay, what numbers can I take the square root of? For example, we can't take the square root of negative numbers, so I'm not going to include any negative numbers in my x values. Again, because we're not working with imaginary numbers, so I doesn't exist in this unit. Sorry, my dog is growling. Silas! Okay, anyway. So the first number, the lowest number we can plug in for x would be our lowest perfect square, which is 0. So if you take the square root of 0, the square root of 0 just equals 0. So that gives you your first x and y value for this parent function, and we'll go ahead and graph that in a second. Our next perfect square, and if you guys want to kind of visualize in your head, remember that chart in my room where we have the list of all the perfect squares above the smartboard? So imagine that middle column in your head. Our next perfect square is going to be 1. The square root of 1 is 1. So again, we're looking for numbers that give us perfect squares. Next perfect square is 4, because the square root of 4 is 2. And then we have 9. 9 is our next perfect square. The square root of 9 is 3. Now I'm going to stop here because for one reason, this gives us plenty of points to plot on our graph. The second reason is, we don't want to scale our graph if we don't have to. So going up to 9 is perfect because we can fit 9 on our graph. So let's go ahead and plot these X and Y values on our graph. Okay, so 0, 0, 1, 1, 4, 2, 9, 3. Before you connect, just a few things to mention. So remember, this is a new function. It's not going to have the same shape as any of the other functions that we've worked with. So it's not going to be a U-shaped graph. It's not going to be a V shape. It's not going to be all curvy. What this graph actually is kind of a ray almost, in the sense that it's a curve that starts at one point. So here, our starting point is 0, 0, and then it keeps going in the other direction. So that's what they mean when they say endpoint. It's kind of your endpoint, starting point, same idea. So here, it is 0, 0. My dogs are fighting over a tree, so just ignore that. Okay, so a big thing here, guys, you do not want to extend the graph past that point. So on these graphs, you should only have one arrow because this is where it stops. So you should never continue past this point with another arrow. I do not want to see that on your graphs, please. Okay, so now let's talk about domain and range. So domain, remember, is talking about your X values on the graph. Range is talking about your Y values. With quadratics, so remember our U-shaped graph, our domain was all real numbers because technically you could have any X value to plug in and you would get a Y value. Here, remember, we can't plug in any X value. So here it all depends on your endpoint. And your endpoint, we're going to reference in a second as kind of H and K. So your domain and range all stem from that endpoint. And you kind of just want to look at your graph. So looking at our graph, our lowest X value is 0. And then as you notice, we keep getting higher and higher X values, and they'll keep going forever and ever. So remember, that's the point of the arrow. So here for domain, and remember, you can write it two different ways. So if you're writing it as an inequality, you can say X is greater than or equal to 0. If you're writing it in interval notation, it would be 0, positive infinity. And remember your bracket and then your parenthesis. I know it's been a little while since we talked about domain and range. So I will be explaining this more with our next example that we do. But again, this number is actually the same as H, or the X value in your endpoint. So those should always match up. Similar with the range, so here range is always talking about the Y values. So here, looking at your Y values, your lowest Y value is 0, and then we just keep getting higher or going higher. So your range, you can write as Y is greater than or equal to 0, so as an inequality, or you could write it just like you did the domain in interval notation, 0, positive infinity. So again, this is just saying that 0 was the lowest this graph is going to go, and then it keeps going up forever. Now, obviously, this will change if you make transformations to the graph. So if you move it left or right, up or down, if you reflect it, these are going to affect the domain and range. And we'll talk about that more in a second with our other example. Here, just quickly filling in the rest of this, x-intercept, where it hits the x-axis, is our ordered pair, 0, 0. y-intercept is the same thing. Here it's just a coincidence, guys, that it's the same as the endpoint. So this is just because that's where it started, but this will change again depending on your equation. The increasing interval, so going from left to right, where is the graph increasing or going up? Here it's from 0 until infinity. And actually this graph is only increasing, it does not decrease, so we do not have a decreasing interval. End behavior, who remembers end behavior? So end behavior is the behavior of the graph as it goes to the left and to the right. So as x is going, or as we're going to the left on the x-axis, so as x is decreasing or going to negative infinity, what's happening with the y value? So if you're looking at the graph as you're going to the left, the graph is going down, so it is going, and it's not going towards negative infinity, because notice it doesn't keep going down forever and ever, it actually stops. So here, remember f of x is the same as y, our y values are actually going to 0, because that's where the graph will stop. So as we are going to the right, so as x is going to positive infinity, our y values are continuing up higher and higher. So here they are going to positive infinity. Okay, so that is the parent function of the square root family. So if you want to now take a second to pause or rewind anything that was maybe confusing, or maybe jot down some questions that you have for me on the parent function, and just let me know, and then we are going to continue on to the right side of the page. Okay, so we just talked about the parent function of the square root family. So now we are going to look at how we can make transformations to that equation. So I would like you to reference the page on transformations of functions in your notebook. I'll put that page on the screen right now. And you're going to notice that it's very similar to what we have on your note sheet. And it's actually very similar to vertex form of quadratics. The main difference here is that instead of parentheses, we have the radical symbol. And notice attached to this radical symbol is this little n here. N represents the index of the radical. And this actually tells us the shape of the graph. Since we're just working with the square root function, for our examples, n is going to equal 2, because when the index isn't written, it's automatically 2. So the shape of our graphs will be the same as what I showed you with the parent function. It'll be a curve that starts at one point and then continues on in one direction. So that brings us to our A value. A tells us the same exact thing as it did with quadratics and all the other functions that we've talked about. So if A is greater than 1, the graph will have a vertical stretch. So in this case, the curve will start to increase more quickly, so it'll have kind of more of an arch to it. If A is between 0 and 1, so this is when we have a fraction, that represents a vertical compression. So that means the curve would be flatter. A also tells us if it is negative, that represents a reflection over the x-axis. So again, this is the same information that we had talked about before when we talked about transformations and when we talked about vertex form of quadratics. Now we are just going to apply that to the square root function. So that brings us to our h value. So remember, h tells you if you're moving to the left or to the right, but here's where you don't want to get tricked, right? If you are subtracting, that means you are moving to the right. And if you are adding, that means you are moving to the left. H also gives us the x value of our endpoint. So I'll talk about that a little bit more in a second. Let's finish up with K. So K tells you if you're moving up or down. If you are adding, or if K is positive, you're moving up. If you're subtracting, you're moving down. K tells us the y value of our endpoint. So let me sum that up right here. So make a little bubble. HK gives us our endpoint. So remember, you never want to go past your endpoint, so these graphs should not have two arrows on them. This is the point where it starts and stops, kind of. Okay, so we have an example down here, and let's just take a look at the equation first and kind of notice the different transformations that are happening, and that can help you predict what the graph is going to look like before we start actually making our table of values. So looking at this equation, let's look at our a value. So here our a value is -2. So it's negative, so that means that we are going to have a reflection over the x-axis. So that means instead of the curve going up, this curve will actually be going down. So that's what the negative tells us. The 2 is separate. That tells us that we are also going to have a vertical stretch. So the curve will be a little bit more expanded vertically. Under here, let's make note of our h value. So here we are adding 3. So that means we would be going left 3 on our graph. So for our endpoint, it would be at -3 for the x value. And then going back to the equation, looking at our k value is -4 or -4, so that means we're going down. So our y value for our endpoint would be -4. So remember, h and k give you your endpoint for the graph. So this gives us also a starting point for our table of values. So I'm actually going to plot that point. So -3, -4. And then I'm going to set up the table of values. So now I'm just gonna squeeze it on the left side over here. So I'm gonna make my 3 columns. In the middle column, I'm going to put our equation. Now, you might be thinking that, okay, so -3, -4 is our endpoint. So here, this is our x value of our endpoint, but Ms. Rock, we can't plug in negatives under the square root. So how the heck are we going to do this? So actually notice what happens when you plug in -3. So that's our endpoint. Also think about it as your starting point for the table. So here I'm going to start with -3 as our x value. So again, going back to that endpoint. Look what happens when we plug in -3. So I'm just going to copy down this equation, plugging in -3 for x. So here, let's take a second, just talk about order of operations. Order of operations says we do parentheses first. Well, parentheses also means grouping symbols. The square root is considered a grouping symbol. So you have to perform whatever operations are under the square root first before you can continue. So we have to combine -3 plus 3 first before we do any other operations. Well, -3 plus 3 gives us 0. And remember, going back to our parent function, 0 is our smallest perfect square. So notice how that works out. So the square root of 0 is 0. Now continuing with the order of operations. So 0 times -2, remember multiplication is in between here, multiplication comes next. 0 times -2 is 0. So 0 minus 4, so notice we get our y value of our endpoint. And that should happen, right? Those should match up. Now the question is, okay, what number do I plug in next for x? Now, this doesn't match up with our parent function, okay? Because if we plug in perfect squares, it's not going to work out with what we have under the square root. So really, you have to think about what you have under the square root and how is that going to give you a perfect square. So your thought process should be, what number, when I add 3 to it, will give us our next perfect square? So here, right, we're not really sure what number we're plugging in yet. You need a number that when you add 3 is going to give you our next perfect square. So if we're going in order, after 0, our next perfect square is 1. So what number, when you add 3 to it, gives you 1? And it is -2. Another way you could think about it, 1 minus 3. So if we're doing the inverse operation, 1 minus 3 gives us -2. Because the goal here, since we don't want to work with decimals, is that under the square root, we need perfect squares. So you have to think about what operations are happening under the square root. So again, just to repeat that, we had the square root of 0. 0 is our first perfect square. Then we want to get our next perfect square, which is 1. So you have to think about what number, when you add 3 to it, will give you 1, because you need to be able to take the square root of this. So I'm just going to bring down the rest of the equation. This is probably one of the harder concepts about this topic, is figuring out what numbers you're plugging in for x. And I'll go through that again when we plug in our next number. So let's simplify this first. Order of operations. So -2 plus 3 is 1. Square root of 1 is 1. 1 times -2 is -2. -2 minus 4 is -6. Okay. And you know what? Let me just draw lines to separate our rows. So question is, what number are we going to plug in next? Well, what's our next perfect square, right? We have 0, we have 1. Our next perfect square is 4. So what number, when you add 3 to it, will give you 4? So we're going to plug in 1 as our next x value. I'm just bringing down the rest of the equation, our a and our k value, just to complete it. Okay, again, so 1 plus 3 gives us 4. 4 is a perfect square. That's what we want. Square root of 4 is 2. 2 times negative 2 is negative 4. Negative 4 minus 4 is negative 8. Okay, let's do one more row in our table. And again, if anything is confusing you, please jot down questions and let me know. Okay, just to reiterate, so we had square root of 0, we got the square root of 1, we got the square root of 4. Our next perfect square is 9. So now we have to ask ourselves, what number, when we add 3 to it, will give us 9? So you should be thinking right now, 6. So 6 is our next x value that we're going to plug in. And again, just filling in the rest of the equation. Order of operation, so 6 plus 3 gives us 9. Square root of 9 is 3. 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. Here, we're going to stop. 4 points is enough for these graphs, and if we kept going, we would be going off the graph. So we are going to stop here, and now we could start plotting. Now guys, as we're plotting, you should be noticing how this graph will match up with the transformations we talked about before. So when we plot these points, you should notice that this graph will be a reflection. It won't be going up. This graph will be going down. You should notice how the endpoint moved over. We already have the endpoint. So let's go ahead and graph the rest of it and you could see what happens. Okay, negative 2, negative 6, 1, negative 8, 6, negative 10. So again, this is going down because of this negative. It is a reflection. Remember, this is your endpoint. We are not going past your endpoint. Please do not draw an arrow in this direction. We are going to connect these points going down, and it's going to continue down forever in this direction. Now, this is going to affect your domain and range, and that will be the next thing that we talk about. Going back to the transformations for a second though, so we talked about how the negative affects the direction. It's going down instead of going up. The 2 made this a little bit of a steeper of a curve. Okay, it's not as flat as the parent function was. H and K moved our endpoint and the whole graph over and down. So now let's talk about the domain and range. So again, domain represents our x values. So x values, you want to think about how far to the left are you going, how far to the right are you going. The lowest x value that we can have is that endpoint, negative 3. We're never going to go past negative 3. So negative 3 is the lowest we can go, and then we just keep getting higher and higher as we move to the right. So as you're moving to the right, these x values are increasing. So here, our domain can be written as x is greater than or equal to negative 3. In interval notation, that would be negative 3, comma, infinity. Our range. Here, our range is affected not only by our endpoint, it's also affected because of that reflection that we had. So notice instead of the y values going up, these y values are going down. The highest y value is where our endpoint is at -4. And then our y values just keep decreasing. So here, y is less than or equal to -4. So this is the highest it goes, and then it just keeps going lower. In interval notation, so remember, interval notation is written lowest to highest. Here, the lowest y value is at -infinity. The highest y value, sorry, I almost knocked the camera over. The highest y value is at -4. Again, these numbers should match your h value and respectively your k value. So these two numbers should match up with your endpoint. Okay, so that is graphing square root functions. So just to sum up a few things. So square root functions are a curve, either going up or going down, that have an endpoint and then continue on in the other direction forever and ever. So again, these graphs should have one arrow, and then just a point at the other end. So not two arrows, not continuing on in the other direction. Domain and range is related to that endpoint. So that h and k value, which again is the same transformations that we've talked about before in the past, and also going back to vertex form of quadratics that you just reviewed last week. When you're making your table, you are plugging in numbers for x that will give you a perfect square under the square root. So you have to think about what operation is happening under the square root and use that to see how that will give you a perfect square. So again, our perfect squares, our lowest perfect square is 0. And then in order, we go 1, 4, 9, 16, 25, 36, 49, etc. But remember, for these graphs, you only need 4 points, and that should be sufficient to give you that curve. So I hope this worked out. I hope I was effectively able to teach you this lesson. Please, please, please stay in touch. Let me know if you have any questions. And I really, really hope I'll be able to see you guys again soon. And I missed you.